In December 2023, Snowflake released the Snowpark local testing framework for Python. Now, generally what happens is if you run a Snowpark application or Snowpark PyTests, it will connect to a Snowflake account and then it will run the tests within a warehouse. With this new feature, we can run the tests and to some extent the pipeline locally in our laptop. Before we see how it works, we'll understand some prerequisites first. It only works with Python 3.8 through 3.11, and it requires you to install the Snowpark Python library with pandas, and the version has to be greater than or equal to 1.11.1. Okay, now we will see how we can use that. Before we can run PyTests, we need to write some fixtures that will provide us the connections or sessions that will be needed to run the tests. Generally, this is how it looks like with a Snowpark application without the local testing framework. It will just build the session with Snowflake account information. This function right here will give us our Snowflake credentials and other things that we need to connect to a Snowflake account to run the tests or run the application. Now, with that information, this fixture can create the session and return to the test functions. Now, if I write PyTest in the terminal and hit execute, it is connecting to a warehouse from that account and running the tests. Now, if we want to use the local testing framework to run the tests locally without connecting to a Snowflake account, we have to make a simple change. That's all we need to do. We just have to replace the existing configuration with local testing set to true. So it will not be account information anymore because it is going to run all the tests in our local laptop. Now, if I run it, it will not going to connect to a Snowflake account or a warehouse to run the tests. All of them run locally. Now, if you look at the time it took to run the tests, you'll understand what happened here. In the first iteration, it ran the tests by connecting to a Snowflake account within a warehouse. It took 3.30 seconds because it has to connect to the warehouse and do back and forth in between running tests. In the local setting, it did not have to do that. Everything was present in the local environment, so it took very less time. And we will see significant improvement in time that it takes when we have more tests. Now, we have to make changes in the code to switch between the local environment and Snowflake account. We will make our fixture a little bit advanced or smart so that we can switch back and forth easily without changing the code. Okay, we have added one PyTest add option function that will just add one option. This is a command line option that we can use while running PyTest. And if we set this Snowflake session value to local, it will run the tests in the local environment. And if we just ignore this option altogether and just write PyTest, it will use the Snowflake account to run the tests. Let's try that. Yeah, it took similar amount of time that it took earlier. Now, if we just add that option, it is going to use the local laptop environment to run the tests. And as we can see, the time it took is very less, at least lesser than what it took while connecting to the Snowflake account. Now we can switch back and forth between using the local environment versus using the Snowflake account easily. We know that we need to have dummy data for the tests, and we create the dummy data within the test functions themselves. But sometimes this test data is big enough that it cannot be put in the function, and we need a separate CSV files or as such to store the test data. Snowpark local testing framework enables us to use that feature. We will see now how it can be used. This test function right here is using the test data from this PyTest data CSV file. And in order to use that file, we need to first store the data from this file or stage that file into an in-memory stage like this. And then we can read this file from that in-memory stage into a data frame. Then that data frame can be used. So we just need to know that or need to remember that the data or the data file needs to be put into an in-memory stage. Otherwise, we will get a file not found error. So we need to have the full path of the file, and then we are just putting this file into an in-memory stage. And this is a name, dummy name. You can name it anything. It won't be created, but it will just be there temporarily for this session while the tests run. Once the session is destroyed, this in-memory stage will also be destroyed. After putting the file into the stage, we need to have the schema set up for that file. So we have these following columns in the CSV file, and we will create the schema like this. we generally create the schema like this, so there is nothing new to it. Now we're just reading the file and passing the schema that we have created. We're reading the file from that stage, just the way we normally read any file from stage. And then we are just using the data frame created out of this data for our test. This Snowpark local testing framework is still in public preview. That means a lot of things are not supported yet. So you may have tests that is not supported right now by the Snowpark local testing framework. And if that is the case, there is a mechanism of skipping the tests while the tests run in local. So we need to add this snippet here, and this is very standard to PyTest. If we want to skip anything based on some condition, we need to add this condition. The main thing is this part, the condition itself. We have added this Snowflake session option in our contest fixture, and this is what we are going to use in the condition to skip the tests if the tests are actually running in local. So this is how we can write a condition for skipping the test. So this test will only run when the tests are running in Snowflake account in a warehouse, and it will be skipped in case of a local run. Let's validate if our skipping mechanism is working or not. This command will run the test in local, this test specifically, as I have mentioned here, and it should be skipped. Yes, it is working. Now we will see if we run the tests in a Snowflake account, if it's running or not. Now we have removed the option to run the test in local. So it should run in a Snowflake account in a warehouse. Let's see if it is running or not. It is running. So this test will only run if it's running in a Snowflake warehouse in an account, but it will skip if we're running the test in local. Sometimes we need to use SQL statements in our pipeline or in the test function, but Snowflake local testing framework does not yet support that. That means Snowflake local testing framework does not support this session.sql function or method. So we can define a mock SQL function that will be used while we are running the tests in the local environment. But I did not find any use to patch this session.sql method. Let me know in the comment if you find any use. Now we'll just do a test run for this function to see if it is working in a local environment or not. So we will run this command to test this exact function, or to run the test something function only. As you see, we are using local session and it is running successfully. So patching works, but I don't see any use. As we already know that this local testing framework is still in public preview, it does not support a lot of things. Just like the session.sql method, it does not support a lot of functions from this Snowflake Snowpark functions module. We will see one example of that, and we will see how to get around that. This two timestamp function from the Snowflake functions module is one of those functions that is not yet supported by the local testing framework. So we'll patch this function so that it runs in the local environment. Now to patch a function, we must ensure that the signature of the patch function, which is this in our case, is aligned with the signature of the actual function, which is this that we are patching. So our two timestamp function takes two arguments of these types. So the first one takes a column or name type argument, and the second one takes a column type argument. Now we will have to make sure our patch function has the same kind of arguments. Since we are just patching it up with mock libraries, we will have column or name equivalent column emulator data type. Now, while running the test in the local environment, the local testing framework will pass the parameters to the mock function instead of the actual function. And the mock function, in turn, will use other mechanism to patch the original function. But in a Snowflake account environment, the original function will be used and the patch function will be ignored. Now let's understand what is happening inside of these functions. This function is very simple. It is taking a data frame as input, and it is taking the column name or the column instance which has the string timestamp in this given format. So the timestamps are in string, but they are in this format. Now this mechanism will convert that column's string values into timestamps, and it will just return the data frame. We will use the two timestamp function to convert the string into timestamps when the tests are running in a Snowflake account environment. But in case of the local environment, the patch function will come in. So the patch function will iterate through all the rows for that column, that is all the string values for the timestamps, and it will convert the timestamp or the strings into timestamps by using this getTime string ptime method. And then it will change the type to Snowflake type. So first it converted the strings into native Python timestamp. This is native Python timestamp. that the string is being converted into. And then that tile will be changed into Snowflake type. So this is that timestamp type, so that it can be used in a Snowflake environment, or it can be used with Snowpark session and data frames. And that's what is being returned. So that local testing framework is actually sending all the data into this batch function, and it is using native Python to convert these strings to timestamps, and then it is changing the data type into Snowflake compatible type right here, and then returning the column itself. And that column will be used here to create this new column. One thing to notice here is that the format of the timestamp, even these two format of the timestamps represent the same string or same format. It's just this one is native Python format, this one is Snowpark format to represent the same string or similar strings. So if we use the two timestamp function directly, this time format or this format will be used to identify the string so that it can be converted into timestamp. But in case of Python, within the mock function, the format is a little bit different, even though they're representing the same. The return value of this mock function is actually a column, and that's what is expected from two timestamp function, because two timestamp function is returning a column type here. Our mock function will return an equivalent of column, which is column emulator. So that's what is being returned here. You see, red column is of type column emulator, which is an equivalent of column type. All right, we have seen how we can use the Snowpark local testing framework. But what's the benefit? The benefit is while running the test, it saves time because it does not need to connect to the Snowflake account back and forth doing the tests, and it can save time, a lot of time, especially for projects with a lot of tests. Now it can also run the pipeline, the whole pipeline to some extent in local environment, but it is not that matured yet. The other benefit is that it saves compute cost because it does not have to use the Snowflake warehouse. Since it is still in public preview, it has a lot of limitations. For example, it does not support the raw SQL strings, or rather, as we have seen, it does not support session.sql method, which is used to run SQL statements. Also, it does not support this kind of expressions where you can use SQL statement snippets to apply filters on. It does not support UDFs, that is user defined functions and user defined table functions, and also stored procedures. Table functions are also not supported. Async jobs. So asynchronous jobs are not supported. Session operations like changing the warehouse or schemas or other things, that is not supported yet. The geometry and geography data types are not supported, and aggregate window function, which means if you want to calculate a sum over windows, it is not supported yet. You can do other window based operations, but not the aggregate ones. And this list is not exhaustive. There is a lot many things that is still not supported by the Snowpark local testing framework, but we hope that in coming years it becomes more mature so that it can be used extensively.